Okay, so this is a discussion of outliers in the context of the data analysis control assessment task. Well, first of all, what's an outlier? Well, it's a result which doesn't agree with the other results in a data set, so in a set of repeats. And if you're looking at a graph, then what that would look like is that one end of the range bar will be a very long way from the line or curve of best fit. Okay. Some important points to note. The word outlier has to refer to a single repeat measurement. It can never refer to an average value. So an average value can't be an outlier. It's the individual repeats that you've done that count as outliers. You shouldn't get rid of them without a reason. Okay, you shouldn't just throw outliers away because you don't like the look of them. If you do discard one, you have to have a very good reason for doing it. Okay, and ideally any result which is an outlier, if you think it is, then you should repeat it again to get a new value. That way you at least have some justification for discarding it, but you should also try and come up with a reason why it went wrong in the first place. And please don't feel like you have to identify some outliers. If you've done your experiment very well, it's entirely possible you won't have any, and all you need to do then is to justify your decision that there aren't any outliers. Okay, so you don't have to go looking for them. It's not essential to have them as long as you point out that you don't have any, and how you know that you don't have any. So, let's have a look at some examples then. So this is a table of some repeat readings for a very simple experiment where you drop a ball bearing from different heights and use a timer to time how long it takes to hit the ground. So, dropped it from 50 centimetres, and these are three repeats: 0.32 seconds, 0.35 seconds, and 0.29 seconds. So the question is, well, is there an outlier in this data set, and if so, where it is, and what might be the cause? And if you have a look around, I mean, the 50, 100, and 150 height drops, the results seem reasonably consistent. Okay, some people would be tempted to say that this third one for the 50 centimetres, the 0.29, is an outlier, and we'll come back to that in a second. I don't agree with that at all. The obvious one is the first result for the 200 centimetre reading. Okay, there it is. And obviously, if you have an outlier and you include it in your average, then it affects the average. So what we should really be doing in that case is to think about, well, why might that outlier have happened? And secondly, what should we do about it? Well, why might it have happened? Well, it's unlikely you've dropped it from a significantly different height than the 200. It would be kind of difficult to do that. So it may be that in writing the results down, this has gone wrong. If you look, that it could be that those two figures have been transposed. So rather than writing down 0.63, they've accidentally written down 0.36. That's one possible explanation. It's hard to imagine it going completely wrong in any other way. I mean, I suppose an error when starting and stopping the timer could also have done that. But we don't know because we haven't done the experiment. When you're doing your experiment, it's important that you think about what the outliers might be as you're doing it. Okay, if you get something that looks like an outlier, was there something that didn't quite go right in that part of the experiment? And if there was, you must admit it. Don't try and hide it. You must admit it and do something about it. So what we should do here is redo the result, and if you redid the result, you might get something like 0.60, which is changed on the table now, and of course that's affected the average, because we've now got the average of these three things. Okay, so you must make sure that you redo the result if you think you've got an outlier, and write down a reason why you think it was there in the first place. Be really careful. There's sort of psychological effects that can come into play when you're trying to identify outliers, and here's an example. So three repeats again: 0.98, 1.01, 1.09. Doesn't matter what the measurements are, we're just interested in the numbers for the moment. So if there's an outlier, which one is it? And again, a lot of people will say 0.98. There's a big psychological impact of not having that one at the front. That one looks like it doesn't fit. But what we care about for identifying outliers is not that, but just how close together the results are. And one way to deal with this is to plot them on a number line so you can see a bit more clearly how far apart they are. And when you do that, it's clear that even though this first result, the 0.98, starts with a 0, and so psychologically you think, oh, that's very different, it's actually the 1.09 that's much further away. Okay, now some of you may have thought that was obvious, that's fine, but it's a very common mistake that people tend to identify outliers just based on this sort of psychological impact. So if you're not sure, plot them on the number line. And then the question is, well, is the 1.09 an outlier? Is it far enough away? It's very difficult to judge that. You've got to make a judgment call. One thing you can do if you're doing sort of a standard set of three repeats is to say, well, that's how far apart 0.98 and 1.01 are, the two that are close together. Is the third repeat more than twice as far away as that? And if it is, you could probably say it's an outlier. I mean, in this case, it's probably difficult, actually. I mean, what you could also do is to take some more repeats and see if you just get a spread that's quite large. Okay, so there are various alternative approaches, and part of doing a good job on the data analysis task is to be adaptive, right, and change what you do. If you're not sure whether that's an outlier, you could take an extra repeat, take a fourth repeat and see. Okay, and write down that that's why you've done that, to help you see whether that's an outlier or not. If your fourth repeat comes in at 0.99, then you've got some more evidence that the 1.09 is an outlier. If your fourth repeat comes in at 1.05, then probably the 1.09 isn't an outlier, and it's just that your results aren't very repeatable. Okay? So, there's no hard and fast rule about outliers. Whenever you identify one, you've got to justify why you think it's an outlier and what you think went wrong. Okay, that's really important. And redo it. So, pause the video then and have a look at this table, see if you can work out where you think the outliers might be in this data set and what you would do with the outlying result when you found one. Okay, so pause it and we'll go through in a second. Okay, so deliberately in here I've stuck a couple of things to try and trick you. If any of you went for those two, well, that's the psychological effect we were just talking about. Here, this 2.99, it's pretty close to these other two. It's just over the sort of 3 meter boundary here. But it's not really far enough away to call it an outlier. And similarly, the 4.02 has just gone up from the 3.9s into the 4s. And psychologically, that's a big thing. But actually, in terms of the spread of the repeats, it's not massive. The most kind of obvious one that is correct is the 1.67. I think that's probably the obvious outlier there. And there are several reasons you could suggest. Again, you haven't done the experiment, so you don't know. But it's very similar to the 10-second charging time. Is it possible they've accidentally done it for 10 seconds for that one? Did the bulb get dimmer for some reason? Was the solar cell kept further away from the lamp? Both of those last two things, note, are a failure to properly control things in your experiment, properly control other variables. We'll talk about this in the other videos, but remember you're trying to assess the effect of your changing your independent variable, which in this case is charging time, on your dependent variable, which in this case is the distance that the little electric car was able to travel. And if you change other things, like the distance to the solar cell from the lamp and the brightness of the lamp, that will affect your results. So outliers can come from a failure of control. And if we had that outlying result, well, again, we would note in your table what we've done. We will think about the reason why. Just note down next to your table, and obtain another result. So you have to do this during your experiment if it's going to be as effective as it possibly can be. Okay, that's it for outliers then.